Video 58. Problem number 2. Prove by induction that a power n minus b power n is a multiple of a minus b for n greater than or equal to 1. Multiple of is same as divisible by, both are equal. Multiple of or divisible by, both are same meaning. Proof. Let p and b a power n minus b power n is a multiple of a minus b. Then p of 1 is a power 1 minus b power 1, n is 1, is a multiple of a minus b. P of k is a power k minus b power k is a multiple of a minus b. P of k plus 1 a power k plus 1 minus b power k plus 1 is a multiple of a minus b. So basic step. In the basic step, you will have to prove p of 1 is true. A power 1 minus b power 1 is a multiple of a minus b. This is true. This is true because a minus b equal to 1 into a minus b. Therefore, a minus b is a multiple of b. This a minus b is a multiple of a minus b. Therefore, p of 1 is true. P of 1 is true. Induction step. Induction step. Assume that p of k is true. That is, a power k minus b power k is a multiple of a minus b. That is, a power k minus b power k is m times a minus b, where m is an integer. Multiple of a minus b, m is an integer. This implies a power k equal to, take minus b power k to that side, plus b power k plus m into a minus b, equation number 1. Now we will prove p of k plus 1 is true. P of k plus 1, here you have a power k plus 1 minus b power k plus 1 equal to, we have to make use of the value of a power k. So split this as a power k into a power 1 minus b power k into b power 1. This is this a into a power k value is b power k plus m into a minus b minus b into b power k, multiplying a into b power k plus am into a minus b minus b into b power k. From this and this you can take b power k common. B power k into a minus b plus am into a minus b. Now you can take a minus b common now. A minus b into b power k plus am. This is an integer. So a power k plus 1 minus b power k plus 1 is a multiple of a minus b, implies a power k plus 1 minus b power k plus 1 is a multiple of a minus b. Therefore, p of k plus 1 is true if p of k is true. Number 2, p of 1 is true. Already we proved p of 1 is true. Therefore, by 2, p of 1 plus 1, which is equal to p of 2, is true. Because whenever it is true for k, it is true for k plus 1 next integer. P of 2 is true. Therefore, by 2, p of next integer 2 plus 1, which is equal to p of 3, is true, etc. Therefore, by induction, p of n is true for all integers n greater than or equal to 1. So this completes the problem 2. Now we make a note, put a equal to 8 and b equal to 3. A equal to 8 and b equal to 3 in above. Therefore, a power n, that is 8 power n minus 3 power n, is a multiple of 8 minus 3, which is equal to 5. Suppose if they ask to prove 8 power n minus 3 power n is a multiple of 5, you will have to prove this problem and take a is equal to 8 and b equal to 3 to get the desired result. So this completes problem number 2 and video 58.